Data breaches occur all the time. If you've ever signed up to an online service, any personal data, including your email addresses and passwords, are sitting on a database somewhere and not always that securely. If this online service is hacked and the database downloaded, all that data will likely end up on the dark web for sale. According to Statista.com, the first half of 2022 saw over 800 data compromises affecting 53 million people in the US alone, and the largest data breach to date exposed over 3 billion Yahoo accounts, where hackers stole poorly encrypted passwords, security questions, and backup email addresses. This is what is meant by being pwned. In other words, your account has been a victim of a data breach. Now, I've been pwned in the past, and the chances are you have too. And in this video, I'm going to show you how to find out whether your password's been pwned. And as always, we're going to use Python to help us out. HaveIBeenPwned.com is a site created by Troy Hunt, and it's been up and running since 2013. Troy created the site shortly after the largest single breach of customer accounts at the time. This was the Adobe breach, which exposed over 150 million accounts, including email addresses, password hints, passwords, and usernames. And because of the scale and frequency of the data breaches, Troy decided to aggregate all the exposed accounts so that victims could first learn that they had been compromised and then take further action to protect themselves. Unfortunately, this list is growing all the time. Now, you can check if your email address has been pwned by typing it in here. And you can do the same with your password here. But I highly recommend you don't do this. Not because I feel this site is illicit, but because you really shouldn't trust any site asking you for your password in this way. It's just a really bad idea. So, how can we find out whether our password's been pwned if we can't enter it into the search field? We can actually send our password anonymously to this website's API. And we do this by creating an SHA-1 hashing algorithm. And even though this algorithm is now out of date and should never be used to store passwords, we can also use something called k-anonymity, which allows us to send only a fraction of our password to the website's API, therefore keeping our password hidden. So just to demonstrate, I'm going to show you how to do this in a Linux terminal, but in a minute, we're going to use Python to automate this process. If we open up a terminal in Linux, we can convert a text string into an SH1 hash using this command here. What we're doing is piping in the string password123 with any new line removed from the end of the string into the OpenSSL function, and asking it to output an SH1 hash. Now, we won't be sending the entire hashed password to the website's API, because this would be equivalent to typing in our password directly into the search field on the website. So what we can do is take the first 5 characters of the hash, or the hash prefix, and send that along using the curl or client URL command. After hitting enter, the API will return a list of around 500 hashes that start with the same prefix. Our job now is to search this list to see if we can find a match for the suffix starting with C600. And as you can see here, we find a perfect match, and it shows us that this password has been exposed over 250,000 times in previous data breaches. This tells us 2 things. Despite this being a really terrible password, many people still use this for their accounts. And secondly, it's likely that this password's various hashes have already been cracked, and this password should therefore never be used again. Now, using the command line in this way can be a bit cumbersome, and you have to remember to delete your command line history because Windows, Linux and Mac store all your commands in a log file. So I'm going to show you how to create a simple Python app using Tkinter so you can check your passwords more conveniently. We'll start by creating 2 variables. one to store the password we want to test, and the other, the API's web address. In order to create an sh1 hash in Python, we have to chain a couple of commands together. First, we need to encode our password string using the UTF-8 encoding system. This converts our string into a stream of bytes, and this is necessary because the hashlib method that we're about to use can only interpret byte strings. The hashlib module provides many different types of hashing functions, including sh1. We need our hash to be in hexadecimal to be compatible with the website's API, so to do this we simply chain the method hexDigest onto the end. We now have our password converted into an sh1 hash in hexadecimal format and stored into a variable. To slice off the first 5 characters, we can write this in the square brackets. And this is basically saying, from index 0 up to, but not including index 5, extract the characters from the sh1 hash variable. The next step is to import the requests module, which allows us to interact with websites, but you will need to do a pip install. On line 20, we're sending a GET request to the website's address with our hash prefix appended to the end, and this will return a response object with all the website's data. If our GET request was successful, we should receive a status code of 200. And finally, to retrieve our list of 500 hashes, we use the text method from the requests module. This will give us our hash suffixes along with the number of times these passwords have been exposed in data breaches. In the next part, I use regular expressions to split this text up into a list of hashes and password occurrences. This will give us the ability to be able to search through a specific hash suffix and record how common this type of password is. I'm not really going to get into regular expressions in this video, but if you're interested, Corey Schaefer has a really good video on his channel that explains them in detail, and I've linked his video in the description. On line 2, we import the regular expressions library. And on line 29 and 30, we compile our regular expression and then use the split function. This function will use the regular expression above to successfully separate the hashes from the password occurrences by using the colon as a delimiter. Printing out our split list, we can see a list of separated hashes and password counts. This means that we can now search for our password hash suffix. And again we use the square brackets to select only the tail end of our password hash, ignoring the first 5 characters. And the upper method converts our result into uppercase, since the API response is also in uppercase. We can now search our split list with the index method. If it finds a match, it will return an index location of that hash in the list. But if no match is found, the index function will return an error. This is why I've used a try except statement, and this allows the program to continue running if an error occurs. Also, if we do find a match, we can also find the number of password occurrences in the pwned database by incrementing the index by 1. And this is what I've just done on line 39. Now, all this code here we can put into a function, and this will be useful later when we create our graphical user interface application. And next we're going to create our graphical user interface to interact with. And we're going to be using the Tkinter framework. First we need to import Tkinter into our project. And all we need to do to create a window is to instantiate the TK class. Lines 12 to 14 modify our window further by changing the title, dimensions, and background color. The main loop method on line 53 tells Python to run the Tkinter event loop. This listens out for things like button clicks and key presses, something we'll need in a moment. And if we run the script now, our main window will pop up. What we can do now is add some label widgets to our window. Our first label widget will be some text that will represent our title. Frame is the name of a rectangular region of our window that our text will reside in. We'll create this frame above shortly. Labels can hold quite a few different arguments that control the look and alignment of text. Application layout in Tkinter is controlled with geometry managers. Here we're using the grid manager. Grid works by splitting a window or frame into rows and columns, and you can control the location of a widget by specifying the row and column numbers. But I've also included a few more arguments to better control the layout of my title. Column span tells the layout manager that I want this widget to occupy more than one column, in my case across 2 columns. The sticky parameter dictates where, within the grid, each label will sit. N means aligned to the top center part of the cell, or the north direction. E means aligned to the right or to the east, and so on. Using all 4 letters will make our label aligned to the center of the grid cell. Lastly, I place some padding around my widget title in the Y direction using the paddy parameter. Before we can test our code, we need to create a frame within our main window and make sure its background is set to the main window's background color. Then we use another geometry manager called pack, and this will ensure our frame stays centered within the main window. We're going to add a few more labels now into our frame, including an entry widget. This can collect any form of user input, but for passwords, we can add in the parameter show star, which ensures anything typed into this field will be hidden. And to make life a bit easier for the end user, I've used the method focusSet, which means you can start typing in your password straight away upon opening the application. On line 66, the check button widget allows us to call a function when we interact with it. The command parameter will call a function called showPassword, which we're about to create in a minute. And this will reveal our password in plain text. The last widget is a button. This button will also call a function called checkPass, which will eventually activate the checkPwned status function that we wrote in the beginning of this section. So that's our app's interface complete. All we need to do now is finish off the showPassword and checkPassword functions. The showPassword function is fairly simple. All we need to do is check if the tick box is checked. If it is, the variable var1 will have a value of 1, in which case we can use the Tkinter config method to change the show parameter in the password entry widget. When the tick box is unchecked, var1 get will return a value of 0, and line 56 will repopulate the password field with stars once again. The checkPass function is a bit more complicated. What I'm doing here is getting the password from the input field and storing it in a variable. Then I pass that variable as a parameter to the checkPwned status function. Instead of having this function simply print out a response, I return it to a variable called response, and I modify lines 47 and 49 by replacing the print command by the return command. We can now do a couple of checks on this response. If the password isn't found from the website's API request, we can create a text widget explaining this to be the case. However, if there's a positive ID, another widget can be generated explaining your password has been pwned. In my final code, which you can download from my GitHub account, I've included ways to clear these output messages when you check a new password. And I've also included the number of times the password has been pwned as well. And that's the app finally complete. Feel free to change or modify the app any way you wish. And in a future episode, I plan to extend this app to include a password generator using the secrets module in Python. If you found this video useful, give it a like and think about subscribing. And I'll see you next time.